This is a multi-part demo that walks through the automated deployment of ceph and cinder on a 2-node cluster. Following that, we're going to set up an all-in-one Kubernetes cluster and demo the KubeVirt data importer and cinder cloning provisioner. Automation here is going to be handled by custom scripts. We will provide links to those scripts in the description. The first node we're going to set up here is the cinder node. We're going to do this using scripts from the setup VM dev repository. Before we get started, we're going to edit the setup config. I've done this ahead of time. The two options here that you're going to want to set are the cinder host and the ceph host. I'm using AWS, so I'm setting these to the internal host names. After that, you're going to want to chmod x the setup CMV script and kick it off. Now this script's going to take about 15 to 20 minutes to run. It's a perfect time to go get a cup of tea or coffee. Now in the interest of time here, we're going to accelerate the video, and in just a second the script will finish. And there you go. We now have a OpenStack, Cinder, and Kubernetes node. Next we'll be deploying ceph on our second AWS node. So now we're going to be setting up the ceph node. It's going to look almost identical to configuring the OpenStack, Cinder, Kubernetes node that we did previously. The same configuration file needs to be edited here, meaning that the same repo that we used for the first one, we need to also have cloned down here. Values to note here, the cinder host and ceph host need to be identical to the other node. They need to have the in this case, the AWS private host name for each of those nodes. We're also going to configure the setup type to CNV ceph. In the previous setup, this was a default value. From there, it's the same chmod plus x, setup CNV dev, and kick it off. Now this script takes considerably less time to run, and we should be done here momentarily. Okay, so it's at this point that we now have a 2-node ceph cluster, and we're going to hop back over to our Cinder OpenStack Kubernetes cluster for the next step of the demo. So we've completed our setup of ceph on our second node, and now we're back on the OpenStack Cinder Kubernetes node. First thing we're going to do is deploy an all-in-one Kubernetes cluster. I'm going to do that by going to the Kubernetes repository and deploying the cluster. Now this is going to take upwards of 5 minutes. While this is going on, we're going to hop down to our second terminal. This is also shelled into the same machine. We're not going to be able to use the terminal that we're deploying the local cluster in. And we're going to wait for that to come up. So now we've got a all-in-one Kubernetes cluster running on next to our OpenStack Cinder deployment on our first AWS node. For space constraints, I'm going to full screen this bottom pane. We do not need the top pane. So thanks to the automation script, we have a set of specs here to get our Cinder dynamic provisioner deployed, and that's going to be handling the cloning operations for our images. There's some configuration that needs to go on in the, with these I've done in the background. If you're doing this yourself, please refer to the documentation. I'm going to go ahead and spin up the provisioner here. Oops, create. I'm going to deploy the secret, the storage class, and the provisioner. Sorry. There we go. And make sure it's running, and make sure the storage class exists. Excellent. So now that we've done that, we're going to use our data import service to fetch a file from a remote location and populate a PVC with it. Again, thanks to the automation scripts, we've got the repository clone down in the root directory. So we're going to hop in there and use the manifest provided for us. Again, there's some configuration that needs to go on in the background here. I've added a couple extra specs just for demonstration purposes. Those would be the checker pod and the cinder clone PVC aren't included in the repository. Those are just sanity checks for our demonstration right now. You can ignore the namespace spec. We are going to be doing this on the default namespace. So let's go ahead and create the importer pod config, importer pod secret, and the importer pod PVC, and wait for this to start going. It's going to take a second for the dynamic provisioner to get that volume up for the PVC. While we're doing that, we're going to look at the config. Now the config file is where we're going to tell the data import service where we want our data to come from. It takes two types of endpoints, either a straight URL, if you are offering files straight through HTTPS or HTTP, or if you're using S3 protocols, we have a S3 client built into the data import service. You can give the server endpoint and the bucket name and object name that you want to bring in. Let's check on our PVC. It's bound. Great. So we're going to deploy the importer pod. Now, right now we're bringing in just a 0-byte file for time. We've tested this with as much as a couple of gigabytes, and it works fine for us. And it is pulling in the image right now. We're just using an Alpine image and running the binary inside of that. There we go. And it will have completed now. Next thing we want to do is kick off the cloning process. So what we are doing is specifying a PVC called the cinder clone PVC in this case, and the provisioner is going to be looking for PVCs with this annotation here. Oops, sorry, that is hard to read. So the annotation reads K8s.io/clone request, and then the name of the PVC object. So our PVC in this case is called golden PVC, and it will be using the standalone cinder provisioner. Sorry, small mistake here. Something important to note, the destination PVC, the one with the clone, needs to match exactly the storage capacity of the PVC being cloned. And we'll go ahead and rename this golden clone. And create the clone now. There we go. And as a final check to make sure that the golden clone now contains a 0-byte file that we've imported into the golden PVC, we're going to execute this checker pod. The checker pod just contains a very long wait inside and mounts the golden clone PVC. And as soon as that is running, we can exec into it and poke into the directory. There we go. Oh, sorry. Because of the way we're doing this, we have to do it via the Docker layer. Now, this isn't always the case. This is just a quirk of local web cluster on AWS. Okay, so now we are on the checker pod. We expect the data directory to contain our 0-byte file. And there it is, hello KubeVirt. So what we've done is set up a 2-node AWS cluster. We've deployed Cinder OpenStack and Kubernetes on one, and Ceph on the other. We've plugged Cinder into Ceph. We've set up a dynamic provisioner that's been altered to handle cloning operations of PVCs, and we've deployed that into Kubernetes. We created a PVC and populated that PVC with remote data using our data service, and then using the clone annotation in our custom PVC, we've cloned the golden PVC into our golden clone. And that is how we have managed to get this data populated from a remote location into Kubernetes. That is all. Thank you very much.